significantly different number, but you get the gist of the information. It's not about the numbers in here. I do that once in a while, so does everybody. I make mistakes, okay? So there it is, example number 4. We're going to do the next problem. So we're actually going to start diving in, and we're going to do some problems for you, okay? Let me just check on the pages, what page we were going to do on some of these. Example 3, example 4, that was page 3. I actually circled them out as, oh, here it is. So we're going to do maybe 3, 9, 15, 21, 33. Okay, these 4 problems. Number 3 says if B is equal to 120 degrees and the angle C is equal to 20 degrees and little c is equal to 28 inches, find little b. This time I pointed to the problem as I was writing it down, so hopefully I didn't get the wrong impression and wrote the wrong problem down. B 120, C 20, C 28. I'm looking for little b. Okay, great. Draw the triangle out every single time before you start. There's big A, big B, big C. B is 120. Little c is 20. There it is right there. I know it's kind of hard to see this a little bit. 120, 20. That's 140. That should be 40 degrees. So little big A is 40 degrees. We really don't need that, but you should find it anyway. We're trying to find little b. There it is right there. And little c is equal to 28. We're going to use the law of sines, LOS for short. That's my 3-letter acronym. Sine of 20 over 20, the ratio of the sine of 20 degrees over 28 is equal to sine of big B over little b. Sine of 120 over question mark little b. Cross multiply, b times the sine of 20. Let's see if I got that right. Yeah, over 28. Multiply those two is equal to 28 times the sine of 120 degrees. Solving for b, I'm going to divide it by the sine of 120. There it is right there. Using my calculator, 28 times the sine of 120 divided by the sine of 20. Here it is right there. I just, if you can see a little bit better, I'm going to use the entry button to show you how it worked out. It says 28, I didn't put times, right here. I didn't put times, so it's 28 sine of 120, and parentheses divided by the sine of 20. You notice I didn't put and parentheses at the end. Do it again. I used my entry button, second entry, to get to that number. It comes out obviously the same one, approximately 70.89. B is approximately, since it's 2 significant figures, I'm going to use 71. And I believe they use, did they use centimeters again? Oh no, they used inches this time. Wow, look at that. So it's approximately 71 inches. Okay. Next problem was number 9. Number 9 says something like this. What do you want, Isaac? No, can you do it a little bit later, please? Thank you. If A equals 52 degrees and big B is equal to 48 degrees and little c is equal to 14 centimeters, find big C first, question mark, and then find little a. Question mark. So you want to find these 2 information sets. Let's draw it again. You can draw it any way you want. Let's call this big A, big B, big C. And A is 52. Big B is 48 degrees. Little c is 14, opposite this angle. So that's 14 And we'll want to find big C first. And we're just going to use our calculator. 180 minus 52 minus 48. It's going to be 80 degrees. So big C is equal to 180 minus 52 minus 48 is equal to 80 degrees. There's your angle. We found it. It's 80 degrees. What are we trying to find? Little a right there. Where is it? Oh, there it is. Here's angle A. Opposite is going to be that side that we're looking for. Okay, question mark. So we use the law of sine. The sine of 52 degrees over the question mark, which is little a, is equal to the sine of, we have to use this one because we don't know this angle at this side. We have to use the angle and this side. So sine of 80 degrees all over 14. We cross multiply. 14 times the sine of 52 is equal to 8 times the sine of 80. To solve for this, we divide by the sine of 80 degrees. Cross it out. Use our calculator. 14 sine of 52 and parentheses divided by the sine of 80. You get used to using your calculator on this. A is approximately 11.2 or 11. And what are the units? The units are in centimeters, and there it is right there. 34 minutes is left. Okay. Some minutes left. The next question I'm going to be doing is probably number 15 from the same book. It says, in which can you find all the missing parts? So this gets a little bit hairy. 15. A is equal to 43 degrees, 30 minutes. C is equal to 120 degrees, 30 minutes. And A is equal to 3.48 feet. So we're missing angle B. We have little a, we're looking for little b, and we're looking for little c. We're going to find all the missing parts. First, we've got a problem, the 30 minutes. To change DMS, if you don't know what DMS is, degrees, minutes, seconds, there's no seconds on this one. To change from 43 degrees, 30 minutes into degree, from DMS into decimal, we just take 43 degrees plus 30, always over 60. That turns out to be 30 over 60 is 1/2, 43.5 degrees. And conversely, for angle C, is 120.5 degrees. That's equal to angle C. Okay, so I'm going to draw the triangle out first. Nice and neat, nice and big. A, B, C. Angle A is 43.5 degrees. Angle C is going to be 120.5 degrees. And we're going to have to figure out what angle B is first. So I'm just going to use my calculator. 180 minus 43.5 minus 120.5. It's going to be 16 degrees. That looks like a really small number. This is so big. This is going to be significantly small. Let's just do this by hand. 120.5 plus 43.5, that's going to be 0. 4, 6, 164. Yeah, that's going to be about right. So angle B is 180 minus that, which is 116 degrees. There it is. And then we'll write it in right there. 16. We have some other information. Little a is 3.48. There it is located right across from the angle. Side A is always opposite the angle. We're looking for little b and little c. Now we can use the law of sines. Sine of c over little c. Sine of 120.5 over little c is equal to, and we know these, sine of 43.5 and 43.5 over 3.48. Cross multiply, c times the sine of 43.5 is equal to, 3.48 times the sine of 120.5. Solving for angle C, I divided by the sine of 43.5. That gets rid of that. Looking at using a calculator, 3.48 times the sine of 120.5 and parentheses divided by the sine of 43.5. We should get approximately 4.36. So little c right over here is 4.36. What are the units on this? Number 15 is going to be in feet. Everything's going to be in feet. Wow, he's starting to break things up a little bit. Okay, we're looking for b right there. We found it. So sine of 43.5 divided by 3.48 is equal to, we're looking for b, so it's going to be the sine of 16 over b. And we cross multiply, b times the sine of 43.5 is equal to 3.48 times the sine of 16 degrees. And to solve for b, we divide it by the sine of 43.5. This is b multiplied, so we have to divide it. Using my calculator on this one, it's going to be 3.48 times the sine of 16 and parentheses divided by the sine of 43.5. This is a little bit rather difficult, tedious process, so make sure you can do this one. Take a little bit of time, slow down. 1.39. That's equal to little b. B. So let's look at this triangle one more time. So this is very important. We want to do the quick check. B is equal to 1.39 and then C is equal to 4.36. Remember, quick check. Biggest angle, biggest side. Is it? Yes. Compared. Smallest angle, by the way, that's 16 degrees right there. Smallest angle, smallest side. Ah. Seems to be right. Pretty close. I'm going to put a little check right there, and there we have it. Okay? A little bit difficult problem, so you want to put a little bit of thought process into these problems as you go. Okay? Should have done straight out. Sorry about that, guys. Impromptu again. 15 is done. Let's do one more problem, or two more problems. We did 15. We're going to try 21. Let's do this one again. I'm not going to solve 21 for you, but we are going to start the process, so I'll give you a little bit of a hint on number 21, as well as one extra problem. They draw you the figure. I'm going to put two problems here. So they draw the figure out for you. It looks something like this. Here's angle C. That's your radius. That's X. That's Y. That's S. That's angle A and angle D. And I could draw this out a little bit bigger for you if you want. Obviously, this is also angle length of radius R. 21 says